Before we get started on this next lesson, let's talk a little bit, or a reminder, I guess, of domain and range. So domain is our inputs and range is our outputs. So for example, if we had this table of values and I wanted to state my domain, I would look at all my x values. Remember, we look to our x column, and so our domain would be 2, 3, 4, and 5. And my range, of course, is my outputs, which is my y values, which would be 4, 6, 8, and 10. Sometimes, though, it's not written as a table. Sometimes we have a graph. In this case, we have this very lovely circle graph. So I'm going to start with my domain. So my domain, because this is a graph, is any real number. And then I want to look at where does this graph begin on my x-axis on the far left, which is right here at -5. And where does it end? It ends right here on my far right at 1. And so I write my statement as x is going to be greater than or equal to -5, but it's less than or equal to 1. Remembering, of course, that if you do this way, it's always the smallest goes first, the largest goes last, and it opens up to the right. Range, on the other hand, let's talk about range. Actually, I think I'll switch colors here. So it's any real number, once again, and I'm looking for my lowest y value, which is right here at -1, and my highest y value, which is right here at 5. And so my y values are going to be y is greater than or equal to -1 and less than or equal to 5. And that gives me my domain and range of that circle graph. Okay, that was just a little bit of a reminder. Today we're going to talk about function notation. So remember yesterday I said we were going to look at functions. We are very concerned about functions. We want to know when we have one. Functions is with every input there's one output. But there's also a very specific way of writing functions, and that's what we'll look at today. So function notation. We need a quick way to indicate inputs and outputs. So this is basically, I want to say about the laziness of mathematicians. We don't want to have to be doing big writing. There has to be an easier way for us to communicate when we're talking about functions, and this is going to be our way of communicating. So let's say we have the function. So here's these points, right? Remember, sometimes we have them in tables, but sometimes we just list out the points. 1, 4, 3, 6, 7, 2, 8, 7, 9, 10. And I'm going to ask you, what is G3? So whenever we have it written this way, so it's G of X equals Y type thing. So this is your input, and this is your output. So if I'm asking you about G of 3, I'm asking you to go to where the input is of 3. So if you go to the input of 3, we can find that right here. Here it is, right there. Then what I'm asking is, what is the output of G of 3? So when we say the output then is 6. And that's all we have to write. Instead of me saying, what is the output if I input 3? I can just put G, how we say it is G of 3. That's what those brackets mean, of. So G of 3. And that's saying the same thing. What is my output if my input is 3? So in thinking about that, let's go to B. What is my output if my input is 9? That's what this G of 9 means. My input is 9. What would my output be? So you would go up back to your coordinate points, look for an input of 9. There it is. And I can see that I have an output of 10. All right. We can actually go backwards with this. So what is my input? What is X if G of X equals 4? So now I'm telling you the output. My output is 4. So I have to find a Y value of 4. Here it is, which means that X must be 1. And what is x if g of x equals 6? So I'm looking for an output of 6. Here's my output of 6. X must be 3. So we can work in either direction, and just realizing that what's inside your brackets is an input and what's outside is the output, okay? So that's going to become very important. What is inside those brackets is your input. All right, so we want a quick way to indicate inputs and outputs of functions. We don't want to have to do a whole lot of writing and explaining. That's not what we like to do. Oops, I'm going backwards. There we go. So let's say we have this function, y equals 3x plus 2. So if x equals 5, then what is the output? Okay, so I want you to take a minute, see if you can figure that out. Feel free to pause this. If x equals 5, then what is the output? Give it a try. Okay, so if you went to your equation, y equals 3x plus 2, and where there was an x, you put a 5, and 3 times 5 is 15, plus 2, so you got your output to be 17, then you are exactly correct. Exactly correct. Good for you. Now, when we talk about function notation, we're talking about easier ways of communicating what we're looking to do. I would get very tired if I had to write out this sentence every single time I wanted to ask you what the output was when I'm giving you an input. And so we have a quicker way to write that other than writing that whole sentence. And that's what I'll show you. Consider the function g of x equals x squared plus 3x plus 1. Determine each of the following. G of 4. So remember on the previous slide where I said this was your input? Well, this is our new way of writing if x equals 4, then what is the output? That's what that little g bracket 4 bracket actually says. Isn't that amazing? So little, so concise, so simple, but yet it means this great big sentence. If x equals 4, then what is the output? Which means I'm going to go to my function, this g of x function, x squared plus 3x plus 1, and I'm going to find g of 4. I'm going to go wherever there is an x, and I'm going to replace it with a 4. 16 plus 12 plus 1, which is 29. 16 plus 12 is 28. 28 plus 1 is 9, which means all that means is that my input was 4, my output is 29. Okay, that's what that means. So instead of writing these great big long sentences, now I can just really be quick and say, hey, find g of -5 for me. So maybe that's your next challenge. Feel free to pause the video right here and see if you can find g of -5. All right, so hopefully when you were asked to find g of -5, you went to your function and wherever there was an x, you replaced it with -5. And you got 25 minus 15 plus 1. So g of -5 is 10 plus 1, which is 11. Okay, so your answer then of g of -5 is 11. What that says is if I put a -5 into my function, then I would get an 11 out as my answer. All right, let's try these. So what if I want to find g of 1 plus g of 2? Well, if I want to find g of 1 plus g of 2, I actually have to go ahead and find g of 1 first. That means wherever there's an x, I am going to replace it with a 1. I'm just going back up just to check my function. Yep, x squared plus 3x plus 1. So wherever there is an x, I'm replacing it with a 1. And then let's figure this out. 1 plus 3 plus 1. So g of 1 is 5. Now let's find g of 2. G of 2 is going to be 2 squared plus 3 times 2, plus 3 times 2 plus 1, which is 4 plus 6 plus 1. And g of 2 equals 11. So if I want to know what g of 1 plus g of 2 is, well, g of 1 is equal to 5, g of 2 is equal to 11, and so g of 1 plus 2 must equal to 16. There's no shortcut there. Make sure you find each one individually and then add them together. Now over here, we're asked to find g of 1 plus 2. Since these are both inside the same bracket, that can actually be simplified. You're just looking to find g of 3. That's me just trying to trick you and see if I got your attention. So because they're both in the same brackets, you can just add them together. You're finding g of 3, which means it would be 3 squared plus 3 times 3 plus 1. So g of 3 equals 9 plus 9 plus 1. G of 3 equals 19. Okay, there is a difference when they're separated than when they are together. All right, let's take a look at a couple more. Oh, this looks strange. Okay, what if we have something totally strange like this? Now, I'm just going to put my function right back up here. So this is what we have. G of x equals x squared plus 3x plus 1. Can I find g of at? Well, I don't even know if that even makes sense. But all I really want you to realize is that it means we're going to take wherever there is an x, and we are going to input an at symbol. So I'm going to go at squared plus 3 times at plus 1, and that's it. G of at is equal to at squared plus 3 at plus 1. So strange. That's like, I don't know. We can't simplify it. We can't do anything else with it. Just, I wanted you to see that we could even throw symbols in there. I could throw other variables in there. So I could put in a y. So that just means I'm going to replace every x with a y. And I get y squared plus 3y plus 1. And that's it. We just leave it like that because we can't put any of those together. So we don't even have to keep using numbers. We could be putting in letters or symbols or anything kind of weird and strange. Okay, last one. Last couple examples, just to kind of go with that whole you can put anything in. So let's say we had these. So g of 6z. G of 6z means that wherever there's an x, I'm going to put a 6z. So I'm going to put 6z squared plus 3 times 6z plus 1. So G of 6z equals 36z squared plus 18z plus 1. And we're done. Okay, I just squared. Make sure when you square something, you square both the coefficient and the variable. All right. Oh, look at this. We can even sub in a whole binomial. Excuse me. So if I put in 2x plus 3, I have to put it into each one of the spots where there's an x. So I'm going to replace my x's with 2x plus 3. So that's going to give me 2x plus 3 squared plus 3 times 2x plus 3. Whoops. Plus 1. Ooh, kind of shoved that in. All right, so g of 2x plus 3. Now, that 2x plus 3 squared, that's the same thing as 2x plus 3 times 2x plus 3 plus 3 times 2x plus 3 plus 1. Okay, so I want you to realize that squared means the same thing twice. And so to simplify this, I'm going to have to expand that out using my distributive property. So multiply my first term by both terms in the brackets, and I get 4x squared plus 6x plus 6x plus 9. Then I'm going to multiply this 3 inside my bracket, so plus 6x plus 9, and then I have this plus 1. So g of 2x plus 3 is going to equal out to 4x squared. 6 and 6 is 12, plus another 6 is 18, so 18x. And 9 and 9 and 1 is going to be 19. So there we go. Look at that. Huge. Once again, we're expanding. I told you that this expanding and factoring never really go away. All right. So all it means, I just want you to realize, is that when you have some kind of function, instead of writing it as y equals, let's say 2x plus 1, now you're going to notice that a lot of your functions are going to be written f of x equals 2x plus 1. And even though we've replaced the y with an f and x, this means the same thing. Okay, it means the same thing. But the reason why we write it this way instead is so that we can do these quick questions like find f of 3, right? Instead of me having to write if x equals 3, then what is the output, right? That's too long. But by just putting find f3, you know, oh, she wants me to put this 3 into my function wherever there's an x and evaluate it. Okay, so don't be worried if you're now, instead of seeing something written as y equals, we're going to see it written as f of x equals. And that's just because that tells us that we're going to be able to sub values in. It's part of the function notation. And it allows us to see exactly what we're supposed to do quickly, right? It's just a different way of writing things. But either y equals or f of x equals, that means the same thing. Okay, so what happens when we have a function inside of a function? What? That's crazy. So I want you to realize that I could give you more than one function. So f of x equals x plus 3, g of x equals x squared plus 2, and we're going to find f of g of 2, f of g of 2. Okay, so you always start inside. So if you're looking to where you begin, always go to the inside first. So we want to start with g of 2. So let's find g of 2 first. So g of 2 would be 2 squared plus 2, which is 4 plus 2, which is 6. So g of 2 actually is equal to 6. And since g of 2 is equal to 6, I can replace g of 2 inside here. And instead of writing f of g of 2, I can now just write f of 6. Okay, because I know g of 2 is equal to 6. So I want to find f of 6. And if I go to my f of x function, and that's just 6 plus 3, which equals 9. So my answer for f of g of 2 is actually 9. So I started by finding g of 2. I got that answer, and then I found f of that answer, so f of 6, and then I get an answer of 9. So you maybe pause it right here. See if you can find g of f of negative 1, and then unpause it and come back when you're done. All right, so I would start, again, on the inside. I'm going to start with finding f of negative 1. So that's negative 1 plus 3, which is equal to 2. So I know that f of negative 1 is equal to 2. That means I can replace f of negative 1 with a 2, which means I'm only looking to find g of 2, which we already found earlier, 2 squared plus 2, which is 6. Okay, so g of f of negative 1 is equal to 6. Now, what if you're not given a number and instead you're just said find g of f of x? Okay, well, I know what f of x is. F of x is x plus 3. So really what I'm being asked to find is g of x plus 3. So we can replace that whole f of x with that expression x plus 3, which means I'm going to go to my g of x was x squared plus 2. And wherever there is an x, I'm going to replace it with x plus 3. And I get that. Oh dear. Well, that's squared. And we know that squared means the same thing twice. Okay, so I'm going to expand this out. Remember, when you expand, you multiply your first term by both terms in the second bracket, then your second term by both terms in the second bracket. We get x squared plus 3x plus 3x plus 9 plus 2. And then I can simplify that. 2x squared plus 6x plus 11. All right. So I know this is a little bit different, but with a little bit of practice, you'll get accustomed to it and you realize that it's not so bad. Realizing, of course, whatever is kind of inside our brackets, that is our input, and that's what we're going to put into our equation and then see what we get out as an output. I like this graphic. Actually, I find it really funny. So if f of x was Coke cans and g of x is ice, then f of g of x means that we are putting g of x inside of f. Okay, so g of x is inside of f, which means we're putting the ice in the Coke. Whereas if we had g of f of x, that means we're putting the Coke in ice. So that's what this would look like. So a nice little graphic maybe to help you remember what goes inside is in the inside of the brackets, then what goes on the outside. Nice, I like that. I like this kind of picture. Okay, homework is this. 3 questions here that I'm actually going to get you to hand in when you're done. So please, this is to be handed in. Whoops, can't write today. Handed in when completed. I have just a couple of questions. So here's 1 question, here's 2, and here's 3. So what is the difference between f of 0 and f of x equals 0? And if f of x equals x squared plus 5x minus 3 and g of x equals 2x squared plus 4x minus 7, solve g of f of negative 1. And then lastly, if f of x equals x squared plus 3, solve f of 3x plus 2. Okay, so just a few questions that I would like you to complete and then hand in to me when you are done. Awesome. Once again, make sure that if you have any questions that you're reaching out to me. Thanks.